Hello, I'm Chris Robertson. I'm going to go over how I acquired answers from the Insecure quiz software that we use at UCA. I'll be going over some of my thought processes and describing how they can be used to look for similar exploits in different situations. I will specifically be using Quiz 1, which was given by Dr. Paruchuri in the Information Security class at UCA. We were told that the answers were in the web page, so just entertaining my very first thought, I highlighted all of the text on the page to see if there are any hidden letters or characters, but this revealed nothing, as I expected. Several possible ways to score highly on the quiz were discussed in class, but most were simple, brute force, and notified the instructor that someone was attempting to cheat. Thus begins the start of the technical approaches that I followed. First, I thought to inspect the page elements for any hints, paying special attention to the Submit button to see if there was any communication of any kind, or if there were answers listed out in an easy-to-read fashion. This was difficult to go through and didn't prove to be much use at the time, even though it did have the same information that I ended up using, but through another method. What I did end up using and have success with was the View Page Source feature. This is available in all browsers as far as I'm aware, and specifically for Chrome it can be accessed by right-clicking on the web page or using the Ctrl-U shortcut. Immediately shown at the top of the page source window were array initializations of ANDSMAP and POINTSMAP. ANDSMAP looks to be particularly helpful here. Immediately trying to convert the value that ANDSMAP is initialized to simply resulted in the number 7, and since the first answer is a true or false question, it isn't very helpful. So this either means that this array is simply holding what the user input for the answers, or it is the answers themselves just encoded. I open the page source with no answer selected, so it can safely be concluded that ANDSMAP is actually the array of answers, simply encoded. Since the answers are encoded, the web page must either encode the answers provided or decode the ANDSMAP to be directly comparable with provided answers from the user. Simply using the Find feature of Chrome, I searched for ANDSMAP and found where the value of the current question is sent along with the index of the current question to a translate answer function. This is exactly what I was looking for and indicates that the web page is going to decode the ANDSMAP to compare the input from the user. We could also use the Find feature to look for the translate answer function, but in this case it was directly above where we found the function call, so it was easy. Looking in the function, we can identify some key lines. Value equals answer index modulus 31 plus 1. Code equals parse int, with the first parameter being the substring that is the first two characters of the ANDSMAP value provided, and the second parameter of parse int being 16. Finally, new string plus equals string dot from char code, with code XOR value being the parameter. The caret is the bitwise XOR operator in JavaScript. So, question 1 is at index 0, and ANDSMAP 0 is equal to 55. Value is going to equal 0, modulus 31, which is 0, plus 1 to finally equal 1. Code equals parseInt 55, and the second parameter is what base the first parameter is in, so 16 means 55 is in hexadecimal, so parseInt will convert it to decimal, which is 85. Finally, string.fromCharCode converts a provided integer to Unicode. The code provides 85 XOR 1, which is 84. I used an ASCII table because the lower values are the same as Unicode, so 84 is converted to the character T. T is an acceptable answer for our true-false question, so that means the answer to the first question is true. So from there, all I needed to do is repeat the process of those 3 lines for all of the remaining answers, and then input the results into the original quiz, and you'll get 100%. This method allows you to acquire all of the correct answers without having to submit the quiz repeatedly or having to check your email. The likely reasons that the quiz software did this was to reduce load on the server hosting the quiz, and to make it so either that the providing server or a separate server does not have to accept and process the information, instead having the client do the calculation and grading. This, however, is insecure, as I have demonstrated, as simply encoding the answers will not prevent hackers from doing this, simply because they can trace the provided decoding function. And it has to have that decoding function, otherwise the web page would not be able to compare the student's answers with the correct ones. A simple solution would be to run this on a Java servlet and simply submit the answers to it, then return the grade without having the answers on the client machine at all.